Here we have a question taken from CSEC Maths January 2007 past paper, paper 2, question 14. So we have question A to C to work out. So what we're going to do is to work each part of the question in turn. So let us look at part A. Given that D equals to the 2 by 2 matrix here and it is singular, so you're asked to determine the values of P. When a matrix is singular, the determinant is equal to 0. So let us first find the determinant of the matrix. So the determinant D implies that we multiply the elements of the leading diagonal, so 1 times 4, and then we find the difference of the product of the elements in the non-leading diagonal. So the elements in the non-leading diagonal is P and 9P, and we find the product of them as well, which the question says that the determinant is, the matrix is singular, therefore the determinant is equal to 0. Okay, let us simplify and solve for P here. 1 times 4 gives us 4, and P times 9P gives us 9P squared, and that equals 0. Let us solve for P. So what I'm going to do first, I'm going to just add 9P squared both sides to get the P on one side. So when I add 9P squared on the left hand side, I get 4. On the right hand side, I get 9P squared. Okay, so we want to get P, so let's get rid of the 9 by dividing both sides by 9. So on the left hand side we have 4 over 9, and on the right hand side we have P squared, which means that we take the square root both sides to get P. So P equals to plus or minus the square root of 4 over 9. So it means that P equals to plus or minus 2 over 3. So P equals 2 over 3 or minus 2 over 3. Let us work out part B of the question now. So part B, you're given the linear equations and you're asked to write the equations in the form AX equals B, where AX and B are matrices. So in this case we're going to write it's in the form AX equals B. So A here represents the 2 by 2 matrix. So to write the 2 by 2 matrix, what we do, we write the coefficients of the X and Y terms in both equations here. So the coefficient of X and Y in equation Y is 2 and 5, and the coefficients of X and Y in equation, second equation, is 3 and 8. Sorry, 3 and 4. Okay, so that's the 2 by 2 matrix A, and XY, X here denotes XY, and B here denotes 6, 8. So we have written the equations in the form AX equals B. Now let us go to part C. Okay, so we have written the matrix in the form AX equals B. So A is a 2 by 2 matrix, so we want to find the determinant of A. So let us find the determinant A. So we multiply the elements in the leading diagonal here, so 2 times 4, and then we find the difference of the product of the elements in the non-leading diagonal, so we do 3 times 5. So we get 2 times 4, that's 8, and 3 times 5, that's 15. So the determinant there equals to minus 7. Now part B, you're asked to show that A inverse is equal to the 2 by 2 matrix here. So let us find the inverse of A. So A inverse The inverse of the matrix really is found when you write 1 over the determinant. So the determinant here is minus 1 over minus 7, so we're going to have minus 1/7. We do 1 over the determinant times the matrix here. Now what we do, we interchange the elements in the leading diagonal. So we interchange 4 with 2, and then we multiply the elements in the non-leading diagonal by minus 1. So minus 1 times 3 there gives us minus 3. Minus 1 times 5 gives us minus 5. And we can simplify this. Minus 1 over 7 times 4 gives us minus 4 over 7. And minus 1 over 7 times minus 3 gives us 3 over 7. Minus 1 over 7 times minus 5 gives us 5 over 7. Minus 1/7 times 2 gives us minus 2 over 7. So we have proved that A inverse is equal to what they asked us to prove. So let us move on to the next part of the question now, which is part C. You're asked to use A inverse to solve for x and y. So we know that A inverse is what we have here. So to solve for x and y, what we do, we use the inverse of the matrix to multiply by the original matrix, which was AX equals B. Remember, you were asked to write AX, write the matrix in the form AX equals B, where A was a 2 by 2 matrix. So here we have the original matrix AX equals B, where A is the 2 by 2 matrix, and then we have B as 6, 8. So to solve for x and y, what we do, we use A inverse to multiply the original matrix here, AX equals B. So on the left hand side, when I multiply by A inverse, I get A inverse times A times x there, and then on the right hand side, when I multiply by A inverse, I have A inverse times B. So let's write this out then. A inverse is minus 4 over 7, 5/7, 3/7, minus 2/7 times A, which is 2, 5, 3, 4, times xy. So that's the left hand side. On the right hand side now we're going to have A inverse times B. So A inverse here is minus 4 over 7, 3 over 7, 5/7, times B, which is 6, 8. So a matrix time, the inverse times a matrix gives us the identity matrix, which is 1, 0, 0, 1, and times xy equals to the right hand side. And you need to know that the identity matrix behaves like the number 1 times xy as well, which just gives us xy. Okay, so all we have to do now is to work out the right hand side. When we work out the right hand side, we get, so upon simplifying the right hand side, we get x as 16 over 7 and y as 2 over 7. So x equals 16 over 7 and y equals 2 over 7. Let us do a quick check to find out whether our values of x and y are correct. So our original equation is 2x plus 5y equals 6. So let's check. So we're going to substitute the values of x and y into the original equation and see if we get the values as shown. So we have 2x plus 5y. So 2 times x there, x is 16 over 7. So 2 times 16, that's 32 over 7, plus 5 times y, which is 5 times 2 over 7. So 5 times 2, that's 10 over 7. So we have two fractions here, so we can add them. So that's 30 plus 10, that's 42 over 7, which gives us 6. So it means that the value of x and y is correct. Let's check the other equation. So we have 3 times 16 over 7, that's 48 over 7, plus 4 times 2 over 7, so 4 times 2, that's 8 over 7. So 48 and 8, that's 56 over 7. 7 into 56 goes 8. So that's correct as well. Thank you for listening, and I hope you do understand how to solve simultaneous equation using matrices method.